angles. This is an inscribed angle, and on an inscribed angle, the key idea is that the measure of this angle right here is half of its intercepted arc. So if that intercepted arc was 100, then the measure of the inscribed angle would be 50. So let's go ahead and look at an example here. In fact, if you want to, kind of guess the answer on your paper or your notes, you can. It says, what are the values of A and B? So over here is angle or arc A, and then down here is angle B. Anybody want to give me either of those? And you might say, Mr. Aaron, don't you normally just do these? I feel like you guys can figure this out without my help too much. Let's start with A. What do you guys think A is?
Wait, then why am I going to complex symbol? That's idiot too.
So A is this arc right here. This is what I want you to focus on right now. That's A. What's the measure of arc A? I'll give you a hint. We're going to use, maybe I'm expecting too much. I just feel like you guys could figure this out. So the rule is this. This angle is half of that intercepted arc. So my question is, what does that arc A have to measure? Nope. I mean, look at it. Does it look like it's 30? I'll give you a hint. It has something to do with this guy right here. This angle right here is 60. So then what? Nope, not 60. Nope. No. Okay, all right, maybe, okay guys, I'll just explain this one, ready? So here's what you need to know. The measure of angle, I'll call it PQT, that's what we're talking about, right? That angle PQT, that's this angle right here, has to be equal to 1/2 the measure of the intercepted arc PT. With me? Now what I'm trying to do right now, of course I'm the geometry teacher, is I'm trying to make my problem look like the formula, the theorem. Do we know what the measure of angle PQT is by chance? Oh, we do. It's 60. So I can put 60 in there. So that's 60. 1/2 is just 1/2. And what is the measure of arc? Remember, this is an arc. This over here is an angle. What is the measure of that intercepted arc? Oh, it's A. What does A have? Guys, how do you get rid of times 1/2? Multiply by 2. So what we're going to do is we're going to multiply both sides by 2. We're going to multiply this side by 2, this side by 2, and I'm going to get a final answer of 120. That's what A is. A is 120 because half of 120 is 60. You see how that worked? Instead of me telling you this over here was 120, and then you would have guessed that to be 60, which you would have, right? I switched it around a little bit. Oh, that was kind of mean, Mr. Allen. Okay, so I did A. Can you find B? Just take a minute, look at it, see if you can figure out what B is. That's what a lot of this math stuff is. It's kind of like a puzzle. You're just trying to figure out the puzzle. And there are rules. The rule that we're focusing on specifically is this one, this theorem 12.11. What do you think B is? Just look at it. Be careful. It's a little bit different. In fact, let me tell you this. It's not 60. The answer is not 60. And I'm going to erase all this work I did over here because I want you to be able to, actually I should probably leave that one thing up here because you do need that. I'll leave this up here. This was, what, 120, right? Yes, sir, Tomas. The whole circle is 360. Is that what you're saying?
Yeah.
Yes, that's true. The whole circle is equal to 360. Anybody have any idea what B is? Once I show it to you, it's going to be easy, right? But, I mean, now that I showed you the 120, it's easy, isn't it? Let me show you that again. Since this arc right here, had this inscribed angle. This is the inscribed angle. Right? So this had to be half of that, and it is. Yeah. Does it look like 15? It doesn't, does it? If this looks like 60, there's no way that looks like 15. Wouldn't you agree? As I should show it to you, you're going to be like, oh my gosh, why didn't I see it? Okay, I guess I'll show it to you unless anyone else. Does anyone on the virtual part want to take a stab on this one?
Is it 75?
It is, Alex, that's exactly right. B is going to be 75. Excellent job, Alex. So let's see why that is. Okay, and guys, as soon as I show it to you, you're going to be like, oh my gosh, I should have got that. All right, so I'm going to erase this stuff over here for a second and get rid of all that. Okay, let's do a baby blue. Do you guys see this arc right here? I guess baby blue wasn't the best. What's the measure of that arc? Well, it's 120 plus that 30 there, right? So what's the measure of that entire arc? 150 degrees. You with me? And so if that's 150, what does B have to be? Well, let me write this down. B degrees has to be 1/2 of the arc PTS. It's actually not a major arc, but I'm going to go ahead and use 3 letters. So it's simply going to be 1/2 times 150, which is exactly 75, which is what Alex said. Good. Good. Does that make sense? Now, you probably couldn't do that one in your head, though. I don't know. Did you guys know 150 divided by 2 is 75? How many of you would need a calculator for that? Yeah, I'd probably grab a calculator too, just to be safe. Right. But if you had to figure it out, I mean, you could. Okay. Are you guys okay on example 1? Now, let me go back and say this again. This is the key theorem for this section. And it says the following. The inscribed angle is half of the measure of its intercepted arc. If this arc is 100, then the inscribed angle is half of that. It's 50. And that's different than what we did a couple weeks ago when we talked about a central angle. If that's 90, then that's 90. Okay? That was a central angle versus an inscribed angle. Okay. Let's go ahead and look at some corollaries. Okay? And these are I think these are kind of intuitive, but you guys gotta let me know. Okay? So I'll go through them and stop me if they don't make sense. You see this blue arc up here? Would you agree that angle A, this angle right here, and angle B, both are inscribed angles to that arc? Would you agree? Therefore, guess what has to be true about those 2 angles? They have to be congruent. In other words, the measure of angle A has to be congruent. Actually, let's not use the word congruent. That's technically not correct. Let's just call it angle A. Let's do it red. Angle A has to be congruent to angle B. Does that kind of make sense? I mean, I think it makes sense, right? If this up here was, let's do 100 again. If that arc is 100 degrees, what does angle A have to be? What does angle A have to be? 50. If that arc up there is 100 degrees, what does angle B have to be? 50. It has to be half. Does that make sense? And by the way, if they're both 50 and 50, they have to be congruent. So that's what this corollary is saying. By the way, corollary is just a fancy word that basically means the same thing as theorem. Okay, so far so good? Okay, now, before we talk about the next one, I have a question for you. What is the measure of that arc right there? I didn't write it on there. What does it have to be? It does not have to be 100. It has to be 180. Why does it have to be 180? Because it's half of, oh, I just wrote 2 degree signs there, sorry. Because it's half of a circle. It's called a semicircle, right? By the way, guys, if that's 180, what does this angle down here have to be then? It has to be half of that. It has to be 90. It's again based on that same theorem. Let me draw this inscribed angle. Here's the inscribed angle. There's the inscribed angle. And what's half of 180? 90. In other words, it has to be a right angle. In other words, the measure of angle C has to be 90. Does that make sense, doesn't it? Again, that agrees with what we looked at there in 12.11. Now, the last corollary is the only one that I think is a little bit hard to understand, but let's see if you can figure it out. I'm just going to read it to you. The opposite angles of a quadrilateral inscribed in a circle are supplementary. Huh. What the heck does that mean? Well, let me ask you this. Do you guys remember what the word supplementary means? What does supplementary mean? You guys remember? It's been a while since we've talked. That's exactly what it means. It means that they add to 180 degrees. It's been a long time. Do you remember what the word complementary means? Adds to 90. That's exactly right. Supplementary means adds to 180. Complementary means it adds to 90. In this case, it said supplementary, so it means 180. So here's what this is saying. Would you guys agree that this angle here, here's what it's saying. Would you agree that those two angles are opposite angles? Angle D is opposite of angle B. It's not opposite of angle A. It's adjacent to angle A. So these two guys are what we call opposite angles, right? And it says that they have to be supplementary. Why is that? Can anyone explain why that's true? In other words, what I'm telling you is the measure of angle D plus the measure of angle B has to be 180 degrees. That's the conclusion to draw. Why? Once you think about it, and once you see it, it makes perfect sense. Why does the measure of angle D plus the measure of angle B have to equal 180? Any ideas? As soon as I show you again, you're going to be like, oh gosh, that makes perfect sense. Yeah. Nope, they're not central angles. Okay, I'll show it to you, okay? In fact, let me show it to you and not use any words, okay? Listen carefully. We're trying to show that angle D and angle B have that up to 180, correct? I'm going to try to show it to you without using any words, and then maybe someone will say, oh, okay, I got it. Maybe not. So here is, well, I'm not helping you. I don't know. Does it make more sense now, or are you still like, I have no idea, Mr. Allen? Just give me the answer. Okay, here's the answer. Guys, you see the arc I just drew? If I put those two arcs together, what's the two arcs together? How much of the circle is it? It's the whole circle. Look at the purple arc. That's this area here. This arc here. And what this when I put those two together, what are you always going to get? You're going to get the full circle, correct? How much does the full circle measure? And what's half of 360? Does that make sense? We use the same. Look, guys, it is this theorem right here. This is the most important theorem of the day. And this theorem says that an inscribed angle is half the measure of its intercepted arc. So when I come over here, these two inscribed angles, they hit the same arc. So that means they have to be congruent. That kind of makes sense. This one here says, hey, if this inscribed angle intercepts a semicircle, well, then it has to be half of the semicircle. Well, that's 180, so it's got to be 90. The last one, which I told you, I said this was kind of the hardest one, right? The last one says this. If you have an inscribed quadrilateral, that's 4 sides, the opposite angles have to be supplementary because they're going to end up, the 2 intercepted arcs are going to be full circle. You know what? One final thing here. Let's see if you can get this one last piece. Let me do this one last thing. Anybody want to take a guess? And you can totally guess on this. What's the measure of angle A and the measure of angle C? Why? You're absolutely right. Because they are opposite angles inscribed in a circle. Has to be 180. I'm telling you that these two, and I'll show you why. Here'd be angle A, here'd be angle C, and guess what those two angles go? They go a full circle, don't they? So what's half of a full circle? Well, it's 180, so the answer is 180. Okay, let's look at an example now. In fact, I'm just gonna do A, and then I'll let you guys try to maybe come up with B, okay? So let's look at A. Mr. Allen, do it. Ready? Here we go. What are we trying to find? We're trying to find the marked angle. So that's this angle right here. Now I want to throw something out at you that's kind of important. Actually, super important. Does anybody know what we call that purple segment that I just drew? I'll give you a hint. It goes through the center. It has a special name. It's a chord, but it's a special kind of chord. Does anybody know what we call it? A what? That is exactly what we call it. We call it a diameter. You guys remember a diameter? Okay, you with me? This one's really, I think, the easy one, right? So here is the inscribed angle, right? There's the inscribed angle. Does the inscribed angle intersect the diameter at the endpoints? And by the way, these numbers here don't mean anything in this problem. They don't mean anything. But what is the measure of this arc right here? 180. So what does angle 1 have to be? Has to be 90. Has to be 90. And it has to be 90 because of corollary 2. Corollary 2 says an inscribed angle in a semicircle has to be a right angle. Guys, this is a semicircle. It's half of a circle. That's what semi means. So semicircle means half a circle, which is 180. So angle 1 has to be half of that, so it has to be 90. Okay. Now, I said I was going to do A, and I was going to let you guys do B. So on B, we're trying to find the measure of angle 2. The measure of angle 2. You do not, I don't want you to guess on this one. I only want you to answer if you feel confident about your answer. Does anybody have any idea of what the answer would be for B? What would be the measure of angle 2? Okay, no one's saying anything. Can I give you a hint without telling you the answer? Would you guys like a hint? Okay, I'm going to show you a hint. I'm going to draw 2 inscribed angles, okay? I'm going to do them in different colors. Here is the first inscribed angle that I want to draw. Are you with me? You see that inscribed angle in green? I think as soon as I show you this other one, I think you're going to see what the answer is. I hope you see. Here's the other inscribed angle I want to show you. Yes. It has to be 38. How many of you were thinking it was 38? You just didn't want to say it. Anybody thinking it was 38? You're just like, I'm not sure if it's 38. I feel like it's 38. Let me explain why it's 38. If this angle, by the way, here's the gist of it. You see this arc right here? Do these two inscribed angles intercept the same arc? Do they have to be congruent? That's exactly what I said up here in this one. Two inscribed angles that intercept the same arc are congruent. It's literally this picture right here. And so that's why the answer there is 38. Okay? Now I want to point something out to you that you might be curious about. This number right here is what we call a distractor. Have you guys ever heard that word? You know what a distractor is? It keeps you from seeing the answer possibly. It's extra numbers. In fact, the truth of the matter is in real life, there's a lot of distractors, aren't there? There's a lot of things that keep us focused on what we need to be focused on. So that's a distractor. So that 70 actually has nothing to do with this problem. Just like over here, this 70 and that 40 really don't have anything to do with this problem either. Those were distractors as well. Does anyone have any questions on this slide? Oh, actually, here, I got a question for you. We were just talking about what a distractor is, weren't we? I have a poll question for you. This will be your last poll question. I'll give you an exit slip too, but there's the poll question if you could answer that. Okay, last theorem. This is the last theorem for today. So we basically had the inscribed angle theorem, and now we've got this theorem. Okay, theorem 12.12. Here's what it says. This right here, let me make sure I write this down. This is what we call a chord. Agreed? That is a chord. Does anybody know what we call this thing right here? I'll give you a hint. It's written in the theorem. Not called a chord because it's not on the inside of the circle. It's called a tangent. This guy is what we call a tangent. You might want to write that on your notes. That's a tangent. Similarly, guess what we call this thing right here, this BC thing? Called a chord. And guess what we call this red thing right here? Call that a tangent. Now this is the thing, that's why I said that first theorem is so important. Look what the theorem says. The theorem says the measure of the angle formed by a tangent and a chord is half the measure of the intercepted arc. Doesn't that seem like the theorem we just talked about? It is. The difference is these are not what we call inscribed angles because they're not on the quote-unquote inside of the circle. The chord is on the inside of the circle, but the tangent is on the outside. So in other words, what I'm trying to tell you is, let me make sure I get this right. Let's say that this arc right here is 100 degrees. If that arc right there is 100 degrees, what is the measure of angle C down there? That chord, or that arc is 100. What does angle C have to be? It has to be 50. Okay, let's do a different one. Let's say that this right here, this big, huge, this is what we call a major arc. Hopefully you guys remember that. That's a major arc. Let's say it measures 200 degrees. What would the measure of angle C have to be now? 100. So this guy turned out to be 50. This guy turns out to be 100. It's like we're doing the same thing over and over and over again. The key idea is half. The idea is half. The angle is half the intercepted arc. Okay? All right, last example. Example 3. would you guys say this is an easy lesson, or is it hard? I feel like it's kind of hard for you guys. I feel like it's hard for you to see. Raise your hand if you think it's kind of easy. Raise your hand if you're like, it's kind of tricky, Mr. I think it's a little confusing. Okay, raise your hand if you're not listening to me right now. Okay, good. Simon says, raise your hand. Put your hands down. Oh, Simon didn't say. Okay, you got it. No, just kidding. All right. So in the diagram, it says that the line SR is tangent to the circle Q. So there's circle Q. They're telling us that that SR line is a tangent, so that's important. They tell us that the measure of this is a major arc. This is all review stuff. We talked about this in section 12.1. The measure of the major arc is 212, and that's PMQ. That means they're talking about this arc right here is 212. That's what the measure of that angle is, or that arc. Their question is, what is the measure? What is the measure of angle PQR? Hey guys, I'm just going to go ahead and do this one, okay? Just to kind of finish this off, and you might be thinking, thank you, Mr. Allen, this is being a problem. All right, now let me show you where that angle is. You guys would agree that that angle is this angle over here, right? It says PQR, so it's that angle there. My point is, we can find this angle. I know that the measure of angle SQP has to be 1/2 the measure of arc PMQ. That's that should be an arc symbol. Let me explain why I know that's half, because it's this theorem. This theorem says the measure of the angle formed by a tangent and its chord is half the measure of its intercepted arc. So here was the intercepted arc on this one. Here's the intercepted arc on this one. Here is the intercepted arc on this one. So here is that angle, if you will. So that angle has to be half of that. In other words, the measure of angle SQP has to be 1/2 of 212. Can you guys do that in your head? What's half of 200? 106. Oops, I almost wrote 160. 106. Agreed? Have I found the measuring PQR yet, though? Very important question. What is the relationship between this angle and this angle? You just have to say one word. You just have to say one word. We've already used the word today. And it starts with the letter S. What is true about those two angles? They are supplementary, because they form what we call a linear pair. Let me write that down. Angle PQR and angle SQP are supplementary. We've already talked about what that means. It means they add up to 180. In other words, the measure of angle PQR plus the measure of angle SQP has to equal 180. Well, we just found the angle SQP. What's that? It's 106. So I'm just going to write plus 106 equals 180. And then over here, I'll just leave this part in red, and that's the unknown part. That's what we're trying to find. Guys, how would we solve that equation? Just subtract 106, right? And what are you going to get? 74. The measure of angle PQR is equal to 74. That's your answer. Okay? 74. Okay, so what I think I'm going to do now, we're going to do you guys want, I was going to do a construction. Is that okay? Just to kind of finish the day, and then we'll be done. But before we do that, if you guys don't mind, I'm going to give you the exit ticket, because I don't want to forget. Sometimes I forget to give the exit tickets in my classes. So I want to send this to you now so that you can answer these questions based on what we did. I hope you got the big idea of today's lesson, which is that I'm not gonna say it, I've said it a bunch. Okay, so I'm gonna let you guys work on that exit ticket. While you're working on the exit ticket, I'm going to start passing out some stuff, because what I wanna do, I'm not gonna verify this one right now. I'm actually gonna do this one here, if you guys don't mind. We're gonna do the hexagon construction, just because it's actually the easiest, and anyways, we're getting close to the end of the time anyways.
The link you gave us was not the exit ticket.
Say that again? Oh, did I send the notes? I'm so sorry, thank you. Thought I grabbed it, but I guess I didn't. I opened it up, but I must not have done it correctly. That looks like the same thing. Huh, why is it not? Is it, I feel like it's just doing the notes over and over again. It is. Huh. Okay, well, let me try this one more time, guys. Maybe I'm just not getting it. It says, here, let's try this. I'm gonna hit short URL. And I'm gonna hit copy. It's still giving the same thing. I don't know why it's not working, guys, so maybe. Oh, I see what's going on. It's not responding. I'm gonna try it. Yes. Yeah. Sorry, guys, I don't need to waste your time. I don't know why that froze, but it did. There we go. Now I'm getting it. Okay, I hope that's the exit ticket now. That's my hope. Please let me know if it's not. Now, guys, can you do me a favor and get out your rulers? By the way, those of you guys that are virtual, we're going to do a construction. So if you're virtual, you're not going to be able to really do that. Are you going to do this over here or over there? Yeah, okay. Yeah, it doesn't matter to me. You can go either place. If they ever give you a compass yet, or a approach, or a compass? Yes. Can you hit refresh? Is anyone else having trouble typing in the exit ticket thing? Okay. Just, you might need to refresh, restart your computer. If you can't get it, don't worry about it. All right, so hopefully everyone's got a piece of paper. And if you would be awesome like Liliana and get out the protractor and the ruler that I gave you last week, that paper protractor ruler, I'm just telling you guys, this is actually a very easy construction. Ooh, I need to quit recording. This is a very easy construction, but